algebraic expression contains one or more variables, an operation, and a constant. So today we talked about what an algebraic expression is and what makes it different from an equation. And an expression is different, and here are examples of algebraic expressions: 5 plus x, 2c minus 3m divided by 4. These are all expressions, but they're different from equations because they're not equal to anything. If I said 5 plus x equals 7, that's an equation because you can solve for x. But because this is not equal to anything, you can't solve anything. So the way expressions work is you would plug in different values for the variables to get different solutions. So I may say evaluate 5 plus x if x is equal to 1, or if x is equal to 2, if x is equal to 3. So that's the difference between an expression and an equation. And whenever you are evaluating expressions, you need to keep some things straight about multiplication. With multiplication, you can show 2 times x, 2x with the letter and the number being right next to each other. You can show multiplication when there is a dot between the number and the variable. You can put parentheses around either the number or the variable, and that will show multiplication. You don't see that too much. But you can do all these ways to show multiplication with a number and a variable. You do not want to use x's to show multiplication when you're using variables because it looks like 2xx. Does that mean 2 times x, and so it gets very confusing with that. So we don't want to use x's for multiplication when we're using variables. Now with numbers, you can still use the x to show multiplication, or you can use the dot, so you can say 2 times 5 this way. You can put parentheses around each of the numbers to show multiplication, but you don't ever want to just put the numbers right next to each other to show multiplication. Even though you can do that with variables, you can't do that with numbers because then that looks like 25. And don't mistake, when we still follow the order of operations when we're solving equations and using expressions. But do not confuse this parentheses with the first parentheses in the order of operations. The parentheses that this is referring to is if you're grouping an operation, like 2 plus 7 or 2 times 7. This is just, the parentheses is simply here just to separate the two numbers. It's not saying that you have to do anything with these numbers first, okay? This still means multiplication, so that would still fall here over on the order of operations. So here's a couple of examples. If I said to evaluate the expression c plus 3 for c is equal to 2, that means that you are really going to replace the c with a 2, so then this is 2 plus 3, and then you can solve it and you get 5. So the answer here would be 5. Now for this problem, if I said to evaluate the expression 5k minus 3 for k is equal to 1, 2, and 6, that means you need to find 3 different solutions because you're plugging in 3 different values for k. So I would say 5 times 1 minus 3, and sorry that looks a little funny over there. So we've got 5 times 1 minus 3. 5 times 1 is 5. 5 minus 3 is 2. We can do 5 times 2 minus 3. 5 times 2 is 10. 10 minus 3 is 7. And then we can do, if k is 6, so 5 times 6 is 30. 30 minus 3 is 27. Another way to evaluate expressions is if they are in a table, and it's kind of like the problem that I just did. You're just going to substitute each of these values for x into the expression right here. So the expression 4x plus 3, if x is equal to 1, means 4 times 1 plus 3. 4 times 1 is 4, plus 3 is 7. The expression 4x plus 3, if x is equal to 2, would be 4 times 2, which is 8, plus 3 is 11. That just looks bad, doesn't it? Kind of messy. The expression 4x plus 3, if x is equal to 4, that is 4 times 4, which is 16, plus 3 is 19. If x is equal to 10, that's 4 times 10, which is 40, plus 3, which is 43. And then we have evaluate the expression if x is 100. So that's 4 times 100, which is 400, plus 3 is 403.